Assalamu alaikum and a very wonderful welcome to everyone. Now here's a quick discussion on the design pad number 6, which is on site investigation. Now let's look at the solution for F1. Now what is specification? A 2 meter square footing is subjected to a contact pressure of 200 kPa. The wet unit weight of the soil supporting the footing is estimated to be 19 kN per meter cube. The water table is estimated to be 9 meter beneath the footing. So you have three information here, 1, 2, and 3. And the required is the minimum depth of test boring. And the solution as follows. The water table is estimated to be 9 meter beneath the footing, and the footing's width is 2 meter. The soil's wet weight should be used. Now from figure F7, this one you can obtain from the slide that I've given you. With a wet unit weight of 19 kN per meter cube, contact pressure between footing and soil equals to 200 kilopascal, and width of footing equals 2 meter. The minimum depth of test boring from figure F7 is estimated to be 7.6 meter. So shouldn't be any problem. Just refer to that F7 figures and you get all this information inside to estimate for the minimum depth of test boring. Now let's look at the second problem. So this one concentrates on standard penetration tests. Specification as follows. An SPT was performed at a depth of 6 meter in sand of unit weight 21.20 kN per meter cube. The blow count was 40, so 40 is the raw blow count. What is required? The corrected N value. Now there are gonna be two equations that you can use. So let's look at the first solution by equation 1. By using equation F1, please refer to your note. The effective overburden pressure is equals to 127.2 kN per meter square, and your estimate, your correction is 0.907. Now this value of 0.907 can also be obtained using figure F11 by locating 127.2 kN per meter square along the ordinate, moving horizontally to the curved line and then moving upward to obtain the correction factor. Therefore, the N corrected is just multiply with the raw SPT value, so it will be roughly about 36. However, if you use the next approach, which is equation F2, your effective overburden pressure is as follows, and the N corrected is 35. Let's look at problem number 3. So the same thing with problem number 1 and number 2, sorry. But it's in different depth and the blow count is 38. Okay, an SPT was performed at a depth of 8.5 meter in sand of unit weight 20.04 kN per meter cube. The blow count was 38. Required the corrected N value. The same procedure with this example. Okay, and in the end you'll get from the first approach, equation F1, the N corrected is 31. However, when you use equation F2, the N corrected is 29. Now let's look at the next one. So it's the same with the third one. However, there is an existence of water table, which is located 1.5 meter below the ground surface. So required, again the same thing, the corrected N value, the solution. So by using equation F1, similar with the previous example, but you just need to counter back the water table, which is just minus 9.8 kN per meter cube. Okay, so the process is similar, and in the end you get N corrected as 42. Now let's look at the last example, which is on vane test specification. A vane tester with a diameter and height of 92 mm and 184 mm respectively requires a torque of 23.50 Newton meter to shear a clay soil, the plasticity index of which is 48%. The soil, what is required? The soil's cohesion. By using equation F3, C is 82 kilonewton per meter square. From figure F22 with a plasticity index of 48%, a corrected factor mu of 0.80 is obtained. Hence, just multiply with the cohesion earlier. You'll get the cohesion corrected as 65.6 kilonewton per meter square. That's all about it. All the problems related for site investigation. Thank you very much.